Good evening, one and all, and today we are going to discuss about the derivation of energy difference in the orbit of an atom. So basically, previously we discussed about energy, that energy inside an orbit is equals to is equals to minus z square e power 4 m upon 8 epsilon naught square n square h square. Now, in order to calculate the difference, we are gonna subtract the higher energy level to lower energy level, which means the outer shell to inner shell, which is equals to E2 minus E1. So accordingly, we are gonna mark their orbits as the outermost orbit's energy level is E2, so its orbit would be N2. If its inner one orbit is E1, so we are gonna mark their orbit as N1. For suppose there are two orbits, uh, there are two orbits. This is N1 and outside it there's N2. Now N1 is having energy E1, N2 is having energy E2. So E2 minus E1 is equals to N2 minus N1. So for orbit of N2, orbit of E2, this is N2, orbit of E1, that is N1. Let's come back to the formula here. As you can see that we have put the values of E2 and E1. Both of the values I have given, that minus mz square e power 4 upon 8 epsilon naught square and square 2 h square minus bracket minus mz square e power 4 upon 8 epsilon naught square and square 1 h upon h square. So accordingly, when we gonna calculate both of them, we will have our answer as mz square e power 4 upon 8 epsilon naught h square 1 upon n square 2, sorry, it's m square e power 4 upon 8 epsilon naught square h square 1 upon n square 1 minus 1 upon n square 2. That's a formula. Now, as the value of uh, hydrogen proton is 1. Hydrogen is having one proton, so we are taking the hydrogen. So here hydrogen is having one proton, due to which we will put the value of z as 1, due to which it will become z is equals to 1, and rest of the equation will become m e power 4 upon 8 epsilon naught square h square. Now this complete equation is equals to 2.18 into 10 power minus 18 joule per atom. But in order to calculate it from 2.18 into 10 power minus 18 into kilojoule per mole, we are gonna calculate it by multiplying it with Avogadro's number and dividing it by 1000, due to which it will ultimately become 1313.359 kilojoule per mole. So that would be 2.18 into 10 power minus 18 joule per atom, 1 upon n square 1 minus 1 upon n square 2. But in order to calculate into kilojoule per mole, that would be 1330.359 kilojoule per mole, 1 upon n1 square minus 1 upon n2 square. I hope this sounds clear. After which we are having frequency. Frequency can be calculated in such a manner that according to Planck's quantum theory, that we are having the value of energy difference is equals to Planck's constant into frequency. Now, in order to calculate this value, we first need to find the energy difference. Energy difference is equals to this value. That energy difference is in such a manner that 2.18 into 10 power minus 18 joule into 1 upon n1 square minus 1 upon n2 square. Now, accordingly, in order to calculate the value of frequency, we are going to move Planck's constant on the other hand side, due to which Planck's constant will move on the other hand side and will multiply with the value of 2.18 into 10 power minus 18 joule per atom. But here, this value is a constant value. We want the numerical form. We want in the algebraic form. So here, me power 4 upon 8 epsilon naught square h square is the actual value. After which, when we are going to multiply it with Planck's constant, it will become e power 4 upon 8 epsilon naught square h cube. Now this is also having a constant value. This is also having a different distinct constant value, which is known as which is around 2906 into 10 power 15 per second, 15 uh, uh, second inverse or hertz. So this is known as 2906 into 10 power 15 hertz with or and into 1 upon n 1 square minus 1 upon n 2 square. Apart from which, this is a formula, and this is having its constant value as 2906 into 10 power 15. Now, in order to calculate the wave number can be calculated in such a manner that here we are having the formula of frequency. Frequency is also having another formula, as we have previously studied. The frequency is equal to wave number into speed of light, which is also derived from another formula. We are going to further discuss this in another class of physics. Uh, but here, frequency is equal to wave number into speed of light. Uh, Wave number into speed of light is equals to frequency. Frequency is having its value as what? As we have previously discussed, this is the value of frequency. This is the complete value of frequency. Now putting this value of frequency here, it will ultimately become z square me power 4 upon 8 epsilon naught square h cube. Now, in order to calculate the value of wave number, c will move on the other hand side, due to which it will ultimately become wave number is equal to z square me power 4 at epsilon naught square h cube c into 1 upon n1 square minus 1 upon n2 square. Now this complete value is also having a constant. This is known as the Rydberg's constant. This is represented by R, known as Rydberg's constant, which is having its value as 1.09678 into 10 s power 7 per meter. As what is wave number? Wave number is the number of waves per unit length. So per meter is the wave number. So here it is having Rydberg's constant, which is 1.09678 into 10 s power 7 per meter. Now we are going to put the value here, due to which the equation will ultimately become wave number is equals to r 1 upon n1 square minus 1 upon n2 square, or we can also put the value directly. So 1.09678 into 10 power 7 1 upon n1 square minus 1 upon n2 square. That's which is of course per meter, because we are calculating the wave number. That's all about today's video. Hopefully you enjoyed it, and we're going to meet in another one.